Moving on now with decimals, we're going to look at the relationship between fractions and decimals. Now, we already looked at this a little bit when we talked about how each decimal place can be written as a fraction with a denominator of a power of 10, right? Like the tenths place, hundredths place, so on. But now we're actually going to also look at converting fractions that aren't necessarily um, in tenths or hundredths or thousandths into decimals. It's really a straightforward thing though, because all you have to do is realize that a fraction means that we're dividing the numerator by the denominator. So if you're going to convert a fraction to a decimal, all you have to do is divide the numerator by the denominator. So it's straightforward, right? So like most of these we know already. So you know probably that a half is 0.5, but why is 1/2 equal to 0.5? Because if we do 1 divided by 2, we get 0.5. 3/4, you know that's 0.75, because if you divide 3 divided by 4, you get 0.75. Okay, what is negative 7/8? It's negative 7 divided by 8, which is negative 0.875. Now there is a different way to do these on the calculator where you can actually just enter them in as fractions. So like if I wanted to enter negative 7/8 as a fraction, I would use that n over d button, and then what I can do is there's this little button above where it says table. See above table it says F double arrow D. That's what you use to convert from a fraction to decimal, or a decimal to a fraction. So right there, negative 7/8, if I convert it into a decimal, it gives me negative 0.875. But honestly, I think division is just as easy. I mean, it's probably actually less keystrokes, right, than actually using that fraction to decimal converter. So that's all you're doing there. Now, what happens though occasionally, we didn't talk about these things yet, but we have what are known as repeating decimals, right? Because if you look back, the ones we just looked at, 1/2, 3/4, and negative 7/8, they were all what we call terminating decimals. They ended, right? But let's say we have something like 1/3. Well, 1/3, if we do this division, ooh, look, it's 0.333333, and it fills up the screen. So this actually would be written as 0.333, and once I've established a pattern there, what I can do is I can use these, what we call ellipses, to indicate that that pattern continues forever, so that you're going to have a 3 repeating infinitely, right? So that's one way to write it in its exact form. The other way to write it in its exact form would be to write 0.3 and place a bar over the repeating digits. So in this case, the repeating digit is a 3. So that would just be 0.3 with a bar over the 3. Now the times that you have to be careful with this is when you have something like, let's say, um, 7/9, right? Like if I do 7/9, what's going to happen? Do 7 divided by 9, and I see 0.777777778. Now what is that 8 really there? That 8 is nothing more than a 7 that got rounded up, because this can only fit in a certain number of decimal places in the calculator screen, but that is really not an 8 there. It's really a 7 that got rounded up. So 7/9 is actually 0.777, and then the ellipses, or 0.7 with the bar. Okay, you can write it either way. And then of course some of them are a little bit wacky. Like let's say you have 1/15, right? What's 1/15? 1 divided by 15, well, that's 0.06 repeating, right? So in this case, we would need to say 0.0666, or 0.06 with the bar, right? Because that 0 is not repeating. That 0 is just there once, and then the 6 repeats. Okay, so you got to be careful with some of these. And then you have like really wacky ones, like let's say 1/7. 1/7 is 1 divided by 7. Look at that. 0.142857143, but really that 3 is that 2 that got rounded up by the 8. So this is one that has an actual 1, 2, 3, 4, 5, 6 digit repeating pattern. So 1/7 is actually 0.1428557, and then that whole pattern repeats again. So I'm not going to write that 3 times and then put the ellipses. I'm just going to write the bar over those 6 digits, right? So it's 0.142857. And then that pattern repeats over and over again. So some of these are a little bit wacky, okay? And then you can even convert these the opposite way. Like, so say you're given 0.3 repeating, the calculator will recognize that if I enter this 0.3 enough times, right? If I keep pressing 3 to show that I'm repeating that pattern, and then I turn that into a fraction by using that fraction to decimal button, it'll give me the 1/3, right? The same thing here with 0.77777. If I enter this 7 enough times, it'll recognize that I want it repeating, and then when I convert it, it'll give me 7/9. So it's kind of a nice feature of the calculators. All right, and then just with a mixed number, I mean, what you can do with mixed numbers is just say like, all right, well, what if I have -2 and 4 fifteenths, right? I know this is going to be -2 point something. So just take the fraction part only, which is 4/15, and divide that, and then it's 0.26 repeating, right? So this is -2.26 repeating. Or again, I could write this as -2.2666, and then the ellipses for the repeating. So you can just, put the whole number part out front, and then just convert the fraction part to a decimal. All right, and then when you're going to order fractions and decimals, it's probably best to convert fractions to decimals first. So like, because the common one that I tend to give is something like 0.3 versus 1/3, right? We just did this. So 0.3 ends, right? That's a terminating decimal. And this is actually a repeating decimal. So they might have the same first decimal place, right? They both have a 3 in the tens place, but 0.3 ends, whereas 1/3 is 0.333 repeating. So you would compare like places, right? So the 3's are equal, but then here, that's really like a 0, and this is a 3. So 1/3 is actually going to be greater than 0.3, right? So 0.3 is less than 1/3. So you got to be careful with ones like that. And then same thing, because you can't confuse rounding with um, ordering, right? So like if I said 0.67 and 2/3, yes, if I round 2/3 to the nearest hundredth, I'm going to get 0.67. But is 2/3 really 0.67? No. 2/3 is 0.666 repeating, and this is 0.67. So here, similarly, I would look at the 6's first. They're equal. But then I would look at the 7's, and 7 is greater than 6. So 0.67 is actually going to be greater than 2/3, right? And again, yes, a lot of times when we're doing things, in real life, we just basically consider them to be equal. 2/3 is 67%, right? Or 0.67. But in reality, it's not, right? 0.67 is slightly greater than 2/3. All right. And then I have some extra videos that go through order of operation problems that have fractions and decimals in them. So you can take a look at those extra videos.